let's continue with integration. So 3.2, definite integrals. So what's the meaning of definite integrals? Definite integrals have the upper and lower limits of integration. So this is an example of definite integrals. We integrate function fx in terms of x, but we are given the limit from a to b. So b here is the upper limit, and a here is the lower limit. Okay, so this is known as definite integrals. We are given the limit from a to b. Okay, so when we differentiate gx in terms of x, then let's say we have fx. Then when we integrate fx, we will get back this gx. Okay, because integration is just the reversation of differentiation. So if we differentiate gx, we will have fx. Then integrate fx, we will get back gx. But this is definite integral. We are given the limits from a to b. So for gx, we have to put a bracket here from a to b. And then what to do with this from a to b? We substitute b to the terms x here. So you will have function g in terms of b. And then minus, after that we substitute a to x here. Function g in terms of a. Okay, so this is the formula. Okay, first we substitute the upper limits to the x here. And then you put minus, substitute a to x here. Okay, so this is the formula. Okay, let's look at the example. Integrate x in terms of x from 1 to 2. Okay, so we do the normal integration first. Integrate x. Okay, this is power 1. So when we integrate it, we plus 1 to the power. So we have x power 2 over the new power, which is 2. Okay, then we are given the limitation from 1 to 2. So don't forget to write from 1 to 2. Okay, we just have to substitute the upper limit to x here. Then you will have 2 square over 2. Okay, the formula is minus. So minus, substitute 1 to x here. So 1 square over 2. So 2 square over 2 is 4 over 2. Minus 1 square over 2, 1 over 2. So the final answer will be 3 over 2. You notice that for definite integrals, we do not have plus c. Okay, we do not need to write plus c. Okay, because for definite integrals, we are given the range from 1 to 2, let's say. So we do not need to write plus c here. Okay, we just need to we just need to put in the limitation 1, 2, and then minus, and then you get the number. Okay, so this is for definite integrals. There are some basic rules for the definite integrals. First one, when we integrate k fx in terms of x from a to b, if you have a constant k here, we can put this k outside. Okay, we can pull out this k. Then k integrate a from a to b function fx dx. Okay, just integrate this as normal. After that, we multiply by k. Okay, number 2, when you have two functions, then we can separate the function and then integrate it one by one. Okay, third rule, integrate from a to b fx dx. This is equals to negative integrate from b to a fx dx. Okay, when we interchange these two, okay, a to b to b to a, then you just need to put a negative here. Last rule, integrate from a to c is equals to from a to b and then b to c. Okay, this is continuously from a to b, b to c is equals to from a to c. Okay, so let's look at the example. Example 11. Evaluate the following integrals. Okay, so start from a. Integrate from 1 to 3 4x minus 1 dx. Okay, so we integrate 4x minus 1. 4x, so you have 4x square over new power 2 minus, okay, integrate 1, you will have x. Then from 1 to 3, from 1 to 3. Okay, after that we just put the upper limit to the x here. So 4, 3 square over 2 minus 3. Okay, minus, okay, we have to substitute 1 to x here. So 4, 1 square over 2 minus 1. Okay, you calculate this, you have the answer 14. Okay, B, integrate from negative 1 to 1, x plus 1, x minus 3 dx. Okay, first step, we expand this. So x multiplied by x. x times negative 3x plus x minus 3. Okay, we expand, then we integrate x squared, so integrate power plus 1, so you have x cubed over the new power 3 minus 2x, so 2x, okay, 1 plus 1, so 2 over the new power 2, 2 can be cancelled out, so x squared minus 3x from negative 1 to 1, negative 1 to 1. Okay, substitute the upper limit first. So 1 cubed over 3, 1 over 3 minus 1 squared, 1 minus 3. Okay, then minus, substitute the lower limit to x here. So negative 1 cubed is negative 1, negative 1 over 3 minus negative 1 squared is positive 1, so negative 1, negative 1 times 3, negative 3 times negative, so you have positive 3. Okay, use a calculator to find, and you will have negative 16 over 3. Okay, for C, integrate negative 1 to 2, x squared plus 2x plus 1 over x power 4 dx. Okay, for this one, okay, we can simplify it first, okay, one by one. So x squared divided by x power 4, you will have 1 over x squared. Then 2x divided by x power 4, you will have 2 over x cubed and 1 over x power 4. Okay, you integrate it. Okay, put the upper limit first, then minus the lower limit. Okay, you will get the answer, negative 9 over 8. Okay, do remember when you have fraction, put it in index form first, then you integrate. Okay, so another example, example 12. Given integrate 0 to 2 fx dx equals to 5. Find the values of the following. Okay, A. Integrate 0 to 2 3fx dx. So 3 here is a constant. By using the first rule, okay, the first rule here, so we can put 3 outside, integrate 0 to 2 fx dx. So integrate from 0 to 2 fx dx is given. This is 5. So just 3 times 5, you will have 15. B. Integrate 0 to 2 3 minus fx dx. So this is the second rule here. When you have two functions, we can separate it. Okay, so we separate it. So it becomes integrate from 0 to 2 3 dx minus integrate 0 to 2 fx dx. Okay, so this one we integrate it ourselves. Integrate 3, so you have 3x from 0 to 2, from 0 to 2. Substitute the upper limit to x here, so you have 6 minus 0. Okay, and then for this one, integrate 0 to 2 fx dx. This is given. This is 5, so minus 5. Then you will have the answer 1. Okay, C. Integrate 0 to 2 fx minus x dx. Okay, this is also rule number 2. We separate them. So separate it into two functions. So integrate 0 to 2 fx dx minus integrate 0 to 2 x dx. Okay, this one we integrate ourselves. So x squared over 2 from 0 to 2. Okay, then you do the same thing. Okay, D. Integrate 0 to 1 fx dx plus integrate from 1 to 2 fx dx. This one is rules number 4. Okay, 0 to 1, 1 to 2, this is equals to from 0 to 2. 0 to 1, 1 to 2 is equals to from 0 to 2 fx dx. So this is just equals to 5. Example 13. Given that y equals to x over 2x minus 1, find dy dx. Hence or otherwise evaluate this. Okay, so first we do the differentiation. Okay, when we differentiate it, okay, this is a fraction and both denominator and numerator have x. So for this one, we have to use quotient rule. Let u equals to x. Let v equals to 2x minus 1. Then du dx will be 1. dv dx will be 2. Still remember the formula of quotient rule? Okay, there will be dy dx equals to v times du dx. v times du dx minus u times dv dx over v squared. This is the formula for quotient rule. dy dx equals to v is 2x minus 1 times 1 minus u dv dx minus 2x over v squared, so 2x minus 1 squared. Then you will have negative 1 over 2x minus 1 squared. Okay, I write it down here. Negative 1 over 2x minus 1 squared. Okay, so this is equals to dy dx. Okay, now the question asks us to integrate this one. So integrate negative 1 to 1 to 2x minus 1 square dx. Okay, so we have to see what's the relationship between this one dy dx and the question given. So this is equals to integrate from negative 1 to 1. Okay, negative 1 over 2x minus 1, but the question is 2 over 2x minus 1 square. Okay, so we have to multiply with negative 2 times dy dx. Okay, because negative 2, okay, negative 2 times dy dx, negative 2 times negative 1 over 2x minus 1 square, we will get back this one. Okay, so you can do like this. And then, so you will have dx cancel out. So integrate negative 1 to 1. 2 is the constant, so we keep it outside, negative 2 here. Then dy. Okay, nothing inside, so this can be 1. Okay, equals to negative 2. Okay, integrate 1 dy, so you will have y from negative 1 to 1. So what is y? Y is x over 2x minus 1. X over 2x minus 1 from negative 1 to 1. Okay, substitute the upper limit to x here. Okay, so negative 2 still outside. So 1 over 2 minus 1. 2 minus 1. Then minus the lower limit here. Negative 1 over negative 2 minus 1. Negative 3. Okay, then you calculate the value. Okay, you will get negative 4 over 3. Okay, example 14. Given that differentiate x squared 3 minus x dx equals to fx, evaluate integrate from 0 to 1 3 minus fx dx. Okay, so from integration we can separate into 2. So integrate 0 to 1 3 dx minus integrate 0 to 1 fx dx. Okay, so integrate 0 to 1 3 dx is just 3x 0 to 1 minus integrate fx. So integration is the reversation of differentiation. So when we integrate fx, we will get back this one. So you just copy down x squared over 3 minus x from 0 to 1. Okay, substitute upper limit first and then followed by the lower limit. Okay, so here you will have 3 minus 0, substitute in 0. Minus, okay, 1 substitute in, so you have 1 over, okay, this is 3 minus 1, 2. Minus, okay, this is 0, okay, 0. So 3 minus 1 over 2, you will have 5 over 2. Okay. SPM format sample 3. Given integrate from 2 to 5 fx dx equals to 3. Find the value of integrate from 5 to 2 fx dx. Okay, so the question gives you from 2 to 5, but here is 5 to 2. Okay, so integrate 2 to 5 fx dx given is 3. So A, integrate from 5 to 2 fx dx. Okay, you can use rules number 3 just now. Okay, put a negative outside, then these 2 we can switch it. So from 2 to 5 fx dx. So negative, okay, this is 3, negative 3. Okay, from B, 2 functions, so we separate it. Okay, separate it. So this one is just 3. And then we integrate this one, 2x from 2 to 5. Substitute 5 to x here, 2 times 5, 10. Okay, 2 substitute in, minus 4. Okay, you will have negative 3. Okay, so let's try C. Find the value of k. Okay, so this is also 2 function. Okay, so let's do it in another color. Integrate 2 to 5 fx dx plus integrate 2 to 5 kx dx equals to 24. Okay, integrate 2 to 5 fx dx is given from the equation. This is 3 plus k is a constant, so we can leave k outside. Then we integrate x. You will have x squared over 2 from 2 to 5 equals to 24. Okay, so we continue. Okay, this 3 we can move it to right hand side. Okay, so this one k, substitute 5 to x here, so 25 over 2 minus, substitute the lower limit, 2 into x here, so 4 over 2 equals to 24 minus 3, 21. Okay, so this one you will have 21 over 2 equals to 21. So k equals to 21 times 2 over 21, so equals to 2. So now do the exercise. 14.2a, question 1, A, C, E, H. Number 2, C, D. Number 4 and number 5.